Alright, in this lesson now we're going to take a look at how we can properly set up our maps back in XSI. Alright, so let's go ahead and import this OBJ from Zbrush back into XSI. So we'll go to File, Import, and let's import the OBJ file. Alright, and we're going to point it to this Rhino Zbrush export, and this is the altered mesh that we've now exported from Zbrush back out and brought back in. So let's go ahead and import this. Now, one of the things that's really nice about XSI is the fact that in addition to bringing in the OBJ file, you can immediately connect in any displacements connected to that OBJ. Alright, so let's go ahead and connect it into this displacement map that we exported previously. And we'll go ahead and press OK. Alright, so here we are. So if I take this mesh, move it back a little bit, and maybe just zoom in a tad, and let's take a render of what we have. All right, you can see overall pretty standard, not a whole lot of detail that's coming through in the displacement. So let's take a look at this object's geometry approximation. And what that'll do is allow us to control just how much or how little this object is subdivided at render time. So with this object selected, we'll go to Selection and take a look at the geometry approximation. Let's open this. We'll take a look inside the Displacement tab, and you can see that XSI by default has these settings in place. Let's alter these a little bit though. Let's switch this to a parametric, which what this will let us do is instead of XSI automatically going through and deciding which triangles need to be subdivided, we'll simplify the process and just give it an overall subdivision, this parametric. So the overall subdivision gets controlled here. So what we basically told it to do is, at render time, subdivide this mesh 2 more times. Okay, so let's render that. Alright, and now you can start to see how a little bit more of this detail starts to come through. Right, now we could actually keep raising these subdivision levels up higher and higher until we capture all the detail that we need. The problem though is that every time we increase that subdivision level, our render time is going to get higher and higher and higher. So typically what I like to do is use the displacement map to start to push out a lot of these larger details, these areas around the neck, these areas around the legs, and so on and so forth. And then what I'll do is use the normal map that we generated to pull out some of the high frequency details. So let's go ahead and set that up. I'll select this object, press 7 on my keyboard to open up the render tree, and let's go ahead and just move this into place. So let's set up the normal map. We'll go to Nodes, down to Bump, and turn on the normal map. Okay, let's go ahead and go to New, and New from File. Alright, and we'll plug in this Rhino normal. Alright, so once we have this hooked up, this normal map can then be plugged right into the bump map port of this default material, or this material that Zbrush automatically imports with your object, or that XSI imports. Alright, now once we render this, what we'll probably see is that this mesh comes back pretty much empty. Right, a lot of black space in here. So what I need to do is select this object, and within the normal map, there's a couple of extra things we have to do. First off, we need to give the normal map a new tangent space. Okay, we'll give it a new color at vertices. Alright, so we'll let that connect up. We'll give this just a moment to think. Alright, and so now the normal map starts to come through. But you'll notice it looks a little bit awkward maybe. Some of these areas are being pushed out where maybe they should be pushed in, and vice versa. So what I'm going to do is use the render compare. I'll middle click, save this. What we need to do in order to get the normal maps to compute correctly is to take this object and actually give it a set of tangents, and that will allow the normal map to work the way it should. So it's a very simple process. Just select your object, go to Get Property, and give it a set of tangents. Okay, so it's going to go through and assign that. All right, you'll see your geometry change color. That's completely normal. So let's take a comparison of what we had before and what we have now. So we'll give this a moment to render. All right, now you can start to see this looks much better. So this is what it looks like now with the tangents applied. And this is what it looked like before. You can see there's a huge difference. So what we have is the displacement map that's able to pull out a lot of these areas that actually need to be raised, but we've relied on the normal map to capture a lot of these high-resolution details. So we really get the best of both. We get the fast render time with a lot of detail. So we can take this. If we wanted to make a few minor adjustments to this, and say maybe we start to drop some of the specular decay, maybe make this color overall a little bit darker. All right, and that'll just sort of soften up those highlights and make those stand through a little bit better. All right, so very nice result overall. We get this very fast render time with this nice high detail. If we want, we could go ahead and finish this off by connecting in the color map as well. So we can go to Nodes, Texture, plug in a image file. Again, new from file. All right, and this time we'll plug in the Rhino color. All right, this Rhino color we can plug right into the Phong itself, into the diffuse port. Okay, now in the lights we may need to actually increase his a little bit with this new image that's been applied to make it stand out a little bit more. So maybe get a new point light. Maybe give it a little bit of color. All right, and this will just sort of move over to the side, just so that we get a little bit of lighting. All right, and let's see how fast this can render out. I'll draw out my render region, and this time I actually won't pause it. We'll take a look at just how fast this can actually render with the help of the normal maps just doing what they need to do, and the displacement maps just doing what they need to do. And then we get this nice little bit of color map that gets added over the top. So really this does render out fast. We have what's now the equivalent of what was a 4 million polygon model in Zbrush that now renders out in just a few seconds. Right. So he's probably still maybe a little bit waxy overall, but we can always come back and make any of these adjustments that we need to at any point in time. Maybe start to back that off a little bit more. Alright, so that's how we can set all of these different maps and our mesh back up within XSI. Alright, so this brings us now to the conclusion of our texturing in ZBrush 3 training kit. So we've had a chance to explore a variety of detailing and texturing workflows that we can utilize to add really a very strong sense of realism to our ZBrush characters. So we've had a chance to look over features like building custom alpha brushes to create sculpted detail. We've looked at how we can layer detail to add a very high amount of complexity to the skin wrinkles on this Rhino. We've looked at how we can simulate the effects of weight and gravity on some of these soft tissues that run through the Rhino's body, and also explore the process of painting these very detailed textures by layering base colors, skin variations, dirt, and wrinkles onto these painted texture maps. So to continue your education, I encourage you to check out the library of training products we currently offer for ZBrush and other popular software applications that are currently being used by students, professionals, and top schools and studios across the globe. Also at digitaltutors.com you'll find additional ZBrush training for sculpting techniques and pipeline integration that will directly complement the one that you've just viewed, as well as the largest resource for free online tutorials.